Introduction. Today is Sunday's morning. Kamal is watching his mother carefully. His mother is putting some white-colored liquid in a bucket of water. He asked his mother about this.
Mother, what is that white-colored liquid?
Son, it is a disinfectant.
And why are you pouring it into a bucket of water?
Because disinfectant is a chemical substance which kills microorganisms and stops their growth. It is used to disinfect floors and toilets.
Mother, can we also use disinfectant directly on wounds?
No, son. We cannot apply disinfectant directly on the wounds. But if we use very low concentrated solution of disinfectant, then we can also use it as an antiseptic.
Mother, I want to know something more about this.
Yes, son. Today I will tell you more about this. Students, today we'll discuss more about this in our chapter Chemistry in Everyday Life. Objectives. At the end of this lesson, you will be able to define and classify drugs, know about drug designing, analyze therapeutic action of different classes of drugs, familiar about chemicals in food, understand artificial sweetening agents, describe food preservatives, define and classify soaps and detergents. Chemical compounds in everyday life. In everyday life, chemical compounds have been employed for a number of useful purposes. For example, sugar is used to sweeten tea, soaps are used for washing and bathing purposes, etc. It influences the existence of human beings and the habitat. Besides those, a number of compounds find application in agriculture, textiles, medicines, photography, etc. Thus, chemicals play a very important role in our daily life and in a number of biological processes. Drugs. Chemical substances used for treatment of diseases and for reducing suffering from pain are called medicines or drugs. Use of some chemical compounds as medicines has helped humanity in a number of ways. Medicines have been used to cure diseases, to reduce suffering from pain, and to check population explosion. They have increased the average lifespan of man and have helped him to lead a comfortable life. The treatment of diseases due to bacterial invasion by chemical compounds, which destroy the microorganisms without affecting the tissues of the host, is known as chemotherapy. The chemicals used for the cure are called chemotherapeutic agents. Classification of drugs. Drugs can be classified in several ways. Based on pharmacological effect. Drugs are classified on the basis of their physiological effect on our body. For example, antipyretic drugs reduce temperature of febrile body, whereas antiseptic drugs prevent the growth of microorganisms. Based on a particular biochemical process. Some drugs affect biochemical processes. For example, antihistamines drugs suppress the action of histamine, which causes inflammation in the body. Based on chemical nature. Some drugs have effect on the body based on their structural features. For example, sulfur drugs can suppress the multiplication of microorganisms like bacteria due to their structure. Therefore, they are used as antibacterial. based on molecular targets. They are based on molecular targets like enzymes, receptors of cells, macromolecules like carbohydrates, proteins, lipids, and nucleic acids. Drug designing. There are two main considerations for designing a drug: drug target and drug metabolism. Drug target. Drugs usually interact with biological macromolecules such as proteins, carbohydrates, lipids, and nucleic acids. These biological macromolecules are called targets. The correct choice of drug target is important to obtain good therapeutic effects of a drug. Drug metabolism. When a drug is administered through the body, it travels through the body to reach its target. A drug should also be designed that it reaches the target without being metabolized in between. Also, the drug should also be designed that after its action, the drug and its water-soluble products, called metabolites, are excreted through urine, feces, exhaled air, saliva, and sweat without causing harm to the body. Drug-target interaction. A biological target is a biopolymer whose activity can be modified by an external stimulus. These macromolecules perform various functions in the body. Those proteins which perform the role of biological catalysts in the body are called enzymes. Those proteins which are crucial to communication system in the body are called receptors. Those proteins which carry polar molecules across the cell membrane are called carrier proteins. Nucleic acids have coded genetic information for the cell. Enzymes as drug targets. Biological targets are mostly commonly proteins such as enzymes because almost all biological reactions are carried out under the catalytic influence of enzymes. In their catalytic activity, enzymes perform two important functions. Enzymes hold the substrate and its active sites in such a position that it can be easily and effectively attacked by the reagent. Enzyme provides functional groups that will attack the substrate and carry out the biochemical reaction. Drugs can either increase or decrease the rate of enzymatically mediated reactions. Inhibition. Enzyme inhibition is the common mode of drug action. Non-specific inhibition. Many drugs are capable of denaturing proteins. These drugs alter the tertiary structure of an enzyme and thus inhibit its action. For example, heavy metal salts, alcohol, formaldehyde, and phenol inhibit enzymes non-specifically. Specific inhibition. Many drugs inhibit a particular enzyme without affecting the others. Specific inhibition may be of two types. Competitive. The drug competes with the normal substrate for their attachment on the active site of the enzyme. Non-competitive. Some drugs do not bind to the active site of the enzyme but bind to a different site of the enzyme, which is called allosteric site. This binding of the inhibitor at allosteric site alters the shape of the active site in such a way that the substrate cannot recognize it and therefore enzyme loses its catalytic property. Receptors as drug targets. Receptors are proteins that recognize and respond to the body's own chemical messengers such as hormones and neurotransmitters. Receptor proteins are located either on the surface of the cell or inside the effector cell. In the body, message between two neurons and that between neurons to muscles is communicated through chemical messengers which are received at the binding sites of the receptor. To accommodate a messenger, the shape of the receptor site changes. This brings about the transfer of message to the cell. Thus, receptors perform two essential functions: recognition of messenger molecule, transduction of the signal into a response. There are a large number of different receptors in the body that interact with different chemical messengers. These receptors show selectivity for one chemical messenger over the other. An agonist is a drug which produces a stimulation-type response. It is a very close mimic of the natural messenger and fits with the receptor site and thus is able to initiate a response. An antagonist drug interacts with the receptor site and blocks the normal response for that receptor. Therapeutic action of different classes of drugs. Now we'll discuss the therapeutic action of few important classes of drugs. Antacids. Acidic pH is necessary in the stomach for digestion of food and good health. But excessive acidity in the stomach causes discomfort, heartburn, and gastric ulcers. The chemical substances which neutralize excess of acid in gastric juices and raise the pH in the stomach to an appropriate level are called antacids. For example, sodium bicarbonate and the mixture of aluminium and magnesium hydroxide are commonly used antacids. Antihistamines. Histamine is a toxic amine and is found along with proteins in nearly all tissues of the body. A number of sensitizing substances called antigens derived from food products, pollens, dust, human hair and sheep wool may cause the release of free histamine in the body, which causes symptoms associated with allergies, hay fever and the common cold. An antihistamine relieves these symptoms by blocking the action of histamine. For example, chlorpheniramine, brompheniramine and Seldane. Antihistamines interfere with the natural action of histamine by competing with histamine for binding sites of receptor where histamine exerts its effect. Neurologically active drugs. These drugs affect the message transfer mechanism from nerve to the receptor. Tranquilizers. These are the drugs used for the treatment of stress and mental diseases. These drugs relieve anxiety, stress, irritability and excitement. For example, chlordiazepoxide and meprobamate are mild tranquilizers. Derivatives of barbituric acid constitute an important class of tranquilizers known as barbiturates. They induce a state resembling to sleep. For example, Veronal and Luminal. Antidepressants. Noradrenaline is important neurotransmitter that plays a role in mood changes. Antidepressant drugs inhibit the enzymes which catalyze the degradation of noradrenaline. For example, iproniazid and phenelzine. Equinol controls depression as well as hypertension. Analgesics. Chemical substances used for relieving pain are called analgesics. For example, aspirin and analgin. They give immediate relief from pain and fever. Aspirin is also used for prevention of heart attacks as it has anti-blood clotting action. Certain narcotics like morphine, codeine, pethidine hydrochloride, methadone, and heroin are also used as analgesics. These do relieve the pain of patient, but they attack the central nervous system and produce sleep and unconsciousness. They are mostly the products obtained from opium and marijuana plants. Antimicrobials. These compounds either inhibit the growth or kill the microbes which cause infection in animals and human beings. Microbial drugs include bactericides, bacteriostatic, and antibiotics. Antibiotics. A substance produced wholly or partly by chemical synthesis, which is low concentration, inhibits the growth and destroys microorganisms by intervening in their metabolic processes. For example, penicillin, ampicillin, and streptomycin. The full range of microorganisms attacked by an antibiotic is called its spectrum. Antibiotics can be divided into two types. Narrow-spectrum antibiotics. These are effective against a very few number of diseases. For example, penicillin. Broad-spectrum antibiotics. These are effective against a wide range of microorganisms. For example, chloramphenicol and tetracycline. Antiseptics and disinfectants. Antiseptics. Chemical substances which prevent the growth of microorganisms or kill them but are not harmful to the living human tissues are called antiseptics. Antiseptics are applied to the living tissues. These are applied to wounds, ulcers, and diseased skin surfaces. Some commonly used antiseptics are Dettol, bithionol, iodine, and hydrogen peroxide solution. Disinfectants. Chemical substances which kill microorganisms or stop their growth but are harmful to human tissues are called disinfectants. These substances are harmful to human tissue. They cannot be applied directly to wounds. They are used to disinfect floors and toilets. For example, phenol, sulfur dioxide, and chlorine. Antifertility drugs. Chemical substances which are used to prevent pregnancy in women are called antifertility drugs or birth control drugs. Progesterone is the most common progestin. Synthetic substances such as neurothindrone have been developed that are superior to progesterone when taken orally to turn off ovulation. They induce temporary infertility. Synthetic estrogens have also been developed and they are often used in oral contraceptive in combination with progestins. A very potent synthetic estrogen is the compound called ethinyl estradiol. Mifepristone is a synthetic steroid that blocks the effects of progesterone and is used as morning after pill in many countries. Chemicals in food. All those chemicals which are added to food to preserve it and improve its appearance, odor, taste, and nutritive value are called food additives. Main categories of food additives are as follows: preservatives, flavoring agents, nutritional supplements, emulsifiers, anti-foaming agents, food colors, artificial sweeteners, antioxidants. These are simply added either to increase shelf life of the stored food or for taste, appearance, and flavor. Artificial sweetening agents. Sweetness is a matter of taste, but almost everyone has craving for sweets. Table sugar and fructose are the most widely used natural sweeteners, but they add to our calorie intake and promote tooth decay. Artificial sweeteners are sweeter than sugar, and they are low-calorie or non-nutritive sweeteners. Aspartame. It is the most widely used artificial sweetener. It is a methyl ester of a dipeptide unrelated to any carbohydrate. It is used in cold foods and soft drinks. Saccharin. It is non-biodegradable and is excreted as such in urine. It has no calorie content. It has proved to be a lifesaver for countless diabetics and is used for those who need to control intake of calories. Sucralose. It is trichloro derivative of sucrose. Its appearance and tastes are like sugar. It is stable at cooking temperature. It does not provide calories. Allitame. It is more stable than aspartame. The control of sweetness of food is difficult while using it. Aspartame is 100 times sweeter than cane sugar. Saccharin is 550 times sweeter than cane sugar. Sucralose is 600 times sweeter than cane sugar. Allitame is 2000 times sweeter than cane sugar. Food preservatives. Those chemicals which prevent undesirable changes in flavor, color, texture and appeal during storage are called preservatives. They delay these changes and prevent spoilage of food due to microbial growth. Preservatives are categorized into two categories. Class 1. Preservatives. It includes table salts, sugar, and vegetable oils. Class 2. Preservative. It includes sodium benzoate, salts of sorbic acid and propanoic acid. Soaps. They are sodium or potassium salts of higher fatty acids like stearic acid, oleic acid and palmitic acid. Soaps are formed by heating fat with aqueous sodium hydroxide solution. The reaction is called saponification. The solution left after removing soap is called spent I, which contains glycerol, which can be recovered by fractional distillation. Sodium and potassium soaps are soluble in water and are used for cleaning purposes. Potassium soaps are soft to the skin, therefore used as bathing soaps. They are prepared by using potassium hydroxide instead of NaOH. Types of soaps. There are different types of soaps depending upon ingredients. Toilet soaps. They are prepared by using better grades of fats and oils, and excess of alkali needs to be removed. Color and perfumes are added to make them more attractive. Transparent soaps. They are prepared by dissolving soaps in ethanol and then evaporating the excess solvent. Glycerol can also be added to get transparent soaps. They are used for dry skins. Medicated soaps. Bithionol is added to impart antiseptic properties to soap. In some soaps, deodorants are added. Shaving soaps. A gum called rosin is added to shaving soap, which forms sodium rosinate, which forms lot of lather. Glycerol is also added to them to prevent drying. Laundry soaps. They contain fillers like sodium rosinate, sodium silicate, borax, and sodium carbonate. Soap chips. They are made by running a thin sheet of melted soap onto a cool cylinder and scraping off the soaps in small broken pieces. Soap granules. They are dried miniature soap bubbles. Detergents. They are sodium or potassium salts of sulfonic acids. For example, sodium alkyl benzene sulfonate. The main advantages of the detergents are the following. They work well even with hard water. They are more effective than soaps. They can work well even with acidic water. They can work well with woolen garments. Soapless detergents. Those cleansing agents which have all the properties of soap but do not contain any soap. They work well even with hard water, acidic water, mineral water, and ice-cold water. Types of detergents. Anionic detergents. The long-chain alcohols are treated with concentrated sulfuric acid to form alkyl hydrogen sulfates of higher molecular mass, and finally alkyl sulfates are neutralized with alkali to form salts. The single anionic detergent is largest used today in household detergents like alkyl benzene sulfonate. They are effective in acidic solutions. These are also used in toothpastes. Cationic detergents. These are mostly acetates or chlorides of quaternary ammonium salts. They are more expensive, therefore used for limited extent as germicides. For example, cetyl trimethyl ammonium bromide. Non-ionic detergents. These are the esters of high molecular mass formed by reactions between polyethylene glycol and stearic acid. Some liquid dishwashing detergents are of non-ionic type. Did you know? The World Health Organization estimates that 80% of the world's population uses herbal medicine. 7,000 compounds used in modern medicine are derived from plants. There are approximately 96,000 kilometers of blood vessels in the human body. Summary. Let us summarize what we have learned. Chemical substances used for treatment of diseases and for reducing suffering from pain are called drugs. Drugs usually interact with biological macromolecules such as proteins, carbohydrates, lipids, and nucleic acids. These biological macromolecules are called targets. Those proteins which perform the role of biological catalysts in the body are called enzymes. Receptors are proteins that recognize and respond to the body's own chemical messengers such as hormones and neurotransmitters. An antagonist drug interacts with the receptor site and blocks the normal response for that receptor. The chemical substances which neutralize excess of acid in gastric juices and raises the pH in the stomach to an appropriate level are called antacids. Tranquilizers are the drugs used for the treatment of stress and mental diseases. Soaps are sodium or potassium salts of higher fatty acids like stearic acid, oleic acid, and palmitic acid. Soaps are formed by heating fat with aqueous sodium hydroxide solution.